So let's start with 46. She was my idol. It's a long story. Next time. 231. So we have f of x equals x squared minus 4 divided by x plus 3. We're asked to do the whole thing, everything, and graph this function. So the question is, how do I know that this function has a slant asymptote? So I'm going to write this for you. A rational function cannot have a horizontal asymptote as well as slant. If it has horizontal, it cannot have slant. If it has slant, it will not have horizontal. And only one type of functions have slant asymptotes. Only one type. So first of all, if a rational function has a horizontal asymptote, it cannot have a slant asymptote. And vice versa, of course. And vice versa. If it has slant, it cannot have horizontal. Which rational functions have a slant? Slant asymptote only when degree at the top is n plus 1 and degree at the bottom is n. Meaning degree 2, degree 3, degree 10, degree 11. Yes?
What about vertical asymptotes?
Oh, vertical asymptotes all of them can have. The vertical asymptote is connected only to the denominator.
Okay.
Yes. All of them can have vertical asymptotes, no matter what type they are. But only one possible situation we have for the slant asymptote, degree 3, degree 2, degree 5, degree 4, exactly by 1 unit higher. Why? Because when I divide degree 4 by degree 3, what degree do I get?
1.
Which is the line. That will be the slant asymptote.
Interesting. So that's because that's the x squared over x. So
Exactly.
2 to 1. But what if it's x squared minus x to the third over x to
But that
1?
would be x cubed. Right. So 3 over 2. You said x squared minus x cubed, you said.
Yeah, over x plus
Squared.
2. No, just x.
No, that's not the slant asymptote.
Okay.
The difference must be 1.
Okay.
Because when you divide, you get x squared, which is not a line. So you have to divide degree 10 by 9, and you get a line. Degree 3 by degree 2, and you get a line. It will not be horizontal. It will be slant. So that's a typical situation. So how do I find it? Does anyone remember long division or synthetic?
Not really. Elementary.
Okay, so let's look at the long division. So very, very easy. It's just simple division. It just is going to look differently. Okay, so if I divide, let's say, 2523 by 11, you can say grab your calculator. True, but I just want to make a point. So 11 goes into 25 twice. I have to go back and multiply. I can say distribute, right? Or multiply 2 by 11. I get 22. But I change the sign to negative 22. Because if I write 22, then I will add and I'll say 47. But that's not what I have to do, right? I have to subtract. But 2 times 11 is not a negative number. It's positive. But before I write, I have to change the sign to the opposite sign. So then I have a 3, and this is nothing, and I bring the next one in line. And it's 22 again, and I do the same thing, negative 22, and then I continue. It's the same process. Of course, you should say, yes?
Where'd you get 32?
So 2 from 5 is 3, and I bring down the next in line.
Okay.
So then 2 times 22, 2 times 2 will be 22, and then I have 10, and so on and so forth, correct? Right? So then I have 10, and I bring the next one down, and I continue.
9.
Good. Is that clear? So I write negative 99, and I will have 4. So how do I write the answer? 2523 divided by 11 is 229 plus 4 over 11. I'm going to use the same method. But of course it's not going to look like this. But it's the same thing. Ready? So we want to start by determining the slant asymptote. So I have, since there is a missing term, what is the degree at the top? Good. But I have a missing term. How do I know? Degree 2 is there, but degree 1 is missing. And degree 0 is there. So they have to be in descending order. And if a degree is missing, I'm going to just leave some room. Yes. And then divide by x plus 3. So the next step is exactly the same with our previous 11. X multiplied by what is x squared? And at the top, we don't lie, right? It is x. Perfect. So then I have this time, since I have two terms, I didn't have two terms with 11. But this time I have two terms, I have to distribute x to both. And I have to change the sign from whatever to the opposite. So x times x is x squared, and I have to write negative x squared. X times 3 is 3x, but I have to write negative 3x. For the same reason, we did not write positive 22, and we wrote negative 22. So these two go away, and then I have negative 3x. I bring down the next in line. And the last question is, x times what is negative 3x? At the top, we do not lie.
Negative 3.
Exactly. Thank you. So negative 3 times x is negative 3x, positive 3x. Negative 3 times 3 is negative 9, positive 9. Gone away, and this is it. So our function, which is x squared minus 4 over x plus 3, can be rewritten how? Can anyone dictate?
229 plus 4 over 11.
So the quotient is x minus 3 plus the remainder over the divisor. And that's exactly what we wrote. Exactly. The 229 plus 4 over 11. Exactly. Yeah. We had up there 229, and we wrote it here, plus we wrote the remainder over the divisor, which is x plus 3. Exactly the same. Any questions so far? So, what are we trying to prove with the horizontal asymptote, really? The behavior of the function over there. What are we trying to prove with the slant asymptote? The behavior of the function over there, not being in the middle. Right? The horizontal asymptote just gives us the tendency or the trend. At infinity, it has nothing about the middle. Same thing with the slant asymptote. So then I only have to find the limit. So the limit at infinity, because that's what it means, of x minus 3 plus 5 over x plus 3. And limit as x approaches negative infinity for x minus 3 plus 5 over x plus 3. Okay, let's start with this part, with the fraction. Every time x approaches a huge number, where does this function go? I have 5 cakes and I want to feed everyone on the planet.
Very tiny. 0.
Right. So this piece, only because x approaches infinity, this piece and this piece will go to 0. Okay. So these two will dictate. Will negative 3 dictate anything? No. Too small. There is no. So when x approaches infinity, where does this go?
Infinity. Positive.
Very good. And about the other one?
Negative.
Which means y equals x minus 3 is the slant asymptote. Just the quotient. How come that this doesn't come into play? Well, how come that this piece does not come into play? Approaches 0 at infinity. Doesn't say anything. So x plus 3 is a linear function with a positive slope. Obviously, the function will come from negative infinity and go to positive infinity, will follow the slant asymptote. Otherwise, it would have followed the horizontal asymptote. Now, what if the answer is negative x minus 3? That's it. That's the only difference. I'm not going to test you on this. I just want you to see an example, and let's graph the function. It's a very good practice because we're going to go through the same steps. F prime, f of x in the middle, and the second derivative. Ready? So remember the function was f of x equals x squared minus 4 divided by x plus 3. Or the other one, x minus 3 plus 5 over, that's fine. I don't need the other part. So what will I do first? I will have to determine what? The domain. Very good. So, and also let's look at the numerator, and I will definitely factor it for the x-intercepts. That's why I need to factor. Okay, so can anyone give us a domain of this function?
Negative infinity to -3.
Excellent.
And then union -3 to positive.
Perfect. So then I have negative infinity, I have -3, I have 0, I have infinity. And obviously, if the function is undefined at -3, so will its derivatives. We already determined this. We calculated it 5 minutes ago. What is it?
Negative infinity and positive.
I'll make myself a note. Y equals x minus 3 is a slant asymptote, so I don't forget to graph it, because every time I graph a function with asymptotes, I have to graph the asymptotes first. Okay, now let's determine the limit, because I need this and this. And also let's plug in 0. I plug in 0. What do I get? Perfect. And when is this function 0? A fraction is 0 only when the top is 0.
-2 and 2.
Excellent. Careful where you put them in. So I just have to find the limits here, left and right. And there is nothing else I can find about the function from the function itself. I'm done. Yes, please. Chloe?
I know you already said this, but can you explain why the -3 is undefined?
Yes, the denominator is 0. We cannot divide by 0. Okay. -3 plus 3 would be 0, and
Oh, okay.
is that okay?
Yeah.
Everyone?
In the top, so if the top were to be 0, again, when it's -2 or +2, then we
Right.
graph it under the -2 and +2. But it doesn't have to be a fraction, right?
Right.
It's just the algorithm.
Yes. Well, when you said it doesn't have to be a fraction, I didn't catch that.
Because it's not -2 or +2 or x plus 3, or it's just
Yes.
-2.
Yes, but when we solve this equation, when we set it equal to 0, only the numerator is 0, because you can put it over 1 and cross multiply.
Okay, gotcha.
And or easier to remember that a divided by b is 0 only if a is 0. There is no other way a fraction is 0, because if the denominator is 0, it's undefined.
Gotcha.
So there is only one option, or you put it over 1 and you cross multiply, and this times 0 is 0. Good. So now let's find these two limits. Limit as x approaches -3 from the left, and limit as x approaches -3 from the right. I prefer this factored form now, because I can plug in numbers easily. -2 divided by x plus 3, x plus 2, x minus 2 divided by x plus 3. So this is a very good practice, just that we have an added element here with the slant asymptote. That's it. Well, the rest is okay. So I have to plug it in. -3 plus 2, -3 minus 2. So this is negative and this is negative, so I have some sort of positive number here in both cases. But what do I have in the denominator? And that's the problem. Exactly. So now I have -3 from the left. Imagine -3.1. What is the sign of negative 3.1 plus 3?
Try with that again.
Yes, negative 3.1 from the left, right? Negative 3.1 plus 3. So that's why we get negative infinity here. And for the other one, negative 3 from the right will be negative 2.9. And negative 2.9 plus 3 will be positive, so that's why. What do we conclude about any function when we determine the limits left and right, or left, or just right, and we get infinity or negative infinity? What do we conclude about this?
It's undefined. Oh, it's going up and
Right,
down.
so
Yeah.
how do we call this? That's it. So obviously, x equals negative 3 is a VA. And I write it here at on my chart, so I don't forget. And of course, on this side is negative infinity, and on this side is positive infinity. I just determined that right here when I put them in. Okay, now we are ready to find the first derivative. I will not use this. This was perfect for finding the limit, but I would like, when I differentiate, I will use this expression, not this one. Ready? So let's find f prime. What method do we have to use, or rule do we have to use here?
Quotient rule.
Quotient rule, very good. Top function prime is 2x times the denominator minus the numerator times the denominator prime. But what is the denominator prime equal to? 1. You don't have to write it. But since I put it in parentheses now, I have no choice. So x plus 3 squared. So let me caution you. If you make the error to simplify this x plus 3 with an x plus 3 from here, everything will collapse moving forward. Because this is part of a term, and this is a factor. We can only simplify factors. Please. Okay, then. So now, let's continue simplifying it. So f prime of x equals 2x squared plus 6x minus x squared plus 4 over x plus 3 squared. I had to distribute 2x and distribute negative 1. And I will simplify to x squared plus 6x plus 4 divided by x plus 3 squared. So what do I do with this? Okay, I found the first derivative. What for? Because I need to find, very good. Will f prime be ever undefined where the function is defined?
No.
No, because the function is not defined at negative 3, and so is the derivative. So the only chance is this. But when is a fraction 0?
Denominator.
Careful, never.
Numerator.
Exactly.
Numerator,
Yes,
yes. That's what I meant.
yes, I know. Very good. This is not factorable. I'm going to find the solutions with the quadratic formula. Negative b plus or minus b squared minus 4ac divided by 2a. I don't need an exact number here. I do need the approximation. So I'm going to put in the calculator. And here's how I recommend we put in the calculator, please. In one step. So left parenthesis around the numerator. You need parentheses around the numerator. So I have negative 6 plus the square root of 36 minus 16 is 20. Close the parenthesis. Oops. Close the parenthesis, close the outside parenthesis, go outside, and then divide by 2. And then the other one, yeah, of course I had to pick a problem with such wonderful x-intercepts. But that's what the real life is. Okay. So I have negative 5 point, I'm just going to truncate this and say negative 0.8. Negative 0.8, and the other one is negative 5.2. Okay. So I found the two solutions. I have to put them in the table. negative 0.8, negative 0.80, and negative 5.2, 0.
Are those the critical numbers?
Yes. So I have to write for f prime 0 and 0, and now I have to determine this value and this value. Of course, I have to squeeze it in. So I go back to the function, which is x squared minus 4. I'll put in the graphing calculator under y equals. So in y equals, parentheses around the top, x squared minus 4 divided by x plus 3. Don't forget parentheses. And I want to go to, of course I forgot, let me check this. So second and table, and I will plug in negative 0.8 and negative 5.2. Okay, so the answer are negative 1.5 and negative 10.5. So a negative 1.5, negative 10.5. Okay, we're done with this, but now we have to study the sign of the first derivative. So let's go back to the first derivative. Here's the first derivative. What is the sign of the denominator? Because I don't want to waste my time with it. So I wouldn't even bother with it. So I will only think about the numerator. So the solutions are negative 5.2 and negative 0.8. So I'm going to plug in negative 10. I'm going to plug in negative 2. And I'm going to plug in 0. When I plug in 0, I should determine it immediately. Yes. Good. So now all I have to do is plug in negative 10 and negative 2 in this top expression to find the sign. So I go back to my calculator, and in y equals, I will de-highlight this and just put in the top. X squared plus 6x and plus 4. And go to second and table, and I want to plug in negative 10, and I want to plug in negative 2. Just give me the sign. Oh, what is that?
You didn't type it in.
Well, what did I do?
There you go.
I just mimicked? I faked it? Plus 6. What did I do?
The indicator was stuck on the equal sign.
That's fine. Thank you very much. So anyway, all I wanted was negative 10 and negative 2. So to the left of negative 10, to the first solution is positive, and to the right is negative. Okay. So of course, here is positive, and here is negative. Now the moment of truth, we want to make sure that the first two rows work well together. What does the function do from negative infinity to negative 10.5?
Increase.
Is that okay?
Yeah.
From negative 10.5 to negative infinity.
Decrease.
Is that okay?
Yeah. Decrease.
Right? From infinity to 0 and to negative 1.5.
Decrease.
Correct?
Yes.
From negative 1.5 to 1 1/3.
Increase.
Negative 1 1/3, and then to 0 and then to infinity.
Increase.
So everything seems to be working well. Up, down, 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 up, because this is negative 1.5 and this is negative 1 1/3. So up and up. Okay? So now the last step is to find the second derivative, which is going to be messy. So I can let you look at it, and we can come up with a graph without it. That's one of the reasons why I put it last, because we can figure out what's happening here. We will not be able to find the inflection points. Now, if we want to find the second derivative, let's do it. Yes?
Sure.
Okay, so let's find the second derivative. I'm going to write the denominator as x plus 3 to which power?
32, 3.
I have to square this, copy the base. Yes, multiply the exponents. Perfect. So now the numerator prime is 2x plus 6 times the denominator, which is x plus 3 squared, minus x squared plus 6x plus 4. Maybe it's not that messy. Times 2 times x plus 3. Because I have to differentiate the denominator, and the inner function is 1. Maybe it's not that bad. Hopefully. I must factor. Don't try to multiply. Don't try to simplify with the denominator. So I see this, and they have a common factor. And that factor is?
X plus 3.
Very good. Good. So here I have a 2x plus 6 times an x plus 3. And here I have 2x squared minus 12x minus 8. So I had an x plus 3 left that I have to multiply by 2x plus 6. And here I took out this, but I have to distribute 2 with a minus in front. Negative 2x squared minus 12x minus 8. Yes, I'm happy for this. I can simplify, and I'm allowed to because it's a factor. That goes away. So now at the top, I will distribute 2x squared plus 6x plus 6x plus 18 minus 2x squared minus 12x minus 8 over x plus 3 to the third. So 2x squared plus 6x plus 6x plus 18. And that's really nice. They probably walked their way back. So these two go away. Wow, these 3 go away. So the numerator is 10 divided by x plus 3 to the third. Does this function have inflection points? Not the derivative, the function itself, f of x. No, because this is never 0. Right? The inflection points are when the second derivative is 0. This cannot be 0. Why? Because it's 0 only when the numerator is 0, and 10 will never be 0. So I will write never 0. No inflection points. However, this function changes sign, though. So let's try, going back to the table, let's try a number that is negative 5 or negative 10. Negative 10 plus 3 is negative 7. Negative 7 cubed is negative. Top is positive, bottom is negative with negative 7. Sign.
Negative.
Let's try 0. 0 plus 3.
3.
3 cubed, positive. 10, positive. Sign.
Positive.
Yes, with these functions is a lot of work. Okay, we're ready to graph. That's all I need. I don't care for anything else but this. I have all the information I need in here. When we graph functions with asymptotes, what do we have to graph first?
Asymptote.
Always. Thank you. This one has 2 asymptotes. One at negative 3. I'm sorry, x equals negative 3. It's a vertical asymptote. And the other one is x minus 3. Y equals x minus 3. I need to graph this line, finding the x and y intercepts. So y equals x minus 3. When x is 0, how much is y? I covered it because it's 0. Y is? Very good. 0, negative 3. Now when y is 0, how much is x? Remember, you have to bring negative 3 to the other side. Very good. So 3 comma 0. These are the points I need to plot in order to graph y equals x minus 3. So 0, negative 3. And 3, 0. Ready? Do not graph it as a solid line. This is not the function. This is only y equals x minus 3. Just the slant asymptote. Ready? I read my chart now. From approaching negative infinity, opening downward, let me plot the points first. So negative 5.2, comma, negative 10.5. So this is negative 3, 4, 5, 6, negative 5.2. So this was negative 3, 1, 4, 5, 6, 7, 8, 9, 10, 11. So right here. Negative 5.2, comma, negative 10.5. Negative 2, comma, 0. Negative 0.8, negative 1.5. 0.8, negative 1.5. 0, negative 4/3. And 2, comma, 0. Okay, ready? So from negative infinity, the function is increasing, opening downward till this point. Okay, fine. It has to approach the asymptote, like it would have approached the horizontal one. Still opening downward, it's coming down to negative infinity on the left-hand side of the vertical asymptote. No problem. On the right-hand side of the asymptote, it's coming from positive infinity, right here, crossing the x-axis at negative 2, 0. Coming, oh, I forgot to ask you, what type of point is positive, negative 5.2, comma, negative 10.5? Very good. What kind of point is negative 0.8, negative 1.5, keeping in mind that this is the sign change? Local? Min. Perfect. Very good. So coming from positive infinity, opening upward all the time on this side, negative 2, 0, a negative 0.8, comma, negative 1.5, crossing the x-axis, crossing the y-axis, crossing the x-axis, going towards infinity. Very clear. Approaching the asymptote at all points in time. So this was function y equals x squared minus 4 over x plus 3. I think it's a little bit beyond the scope of the course. I want you to see an example just in case you run into it. The only thing that is different from any other rational function is the slant asymptote that needs to be determined. Slant asymptote one more time, only when the degree of the top is exactly by 1 unit larger than the degree of the denominator. Okay, enough of that. Let's continue.
You don't have anything like this on your.
Promise. I said it. There is no need for that, really. Okay, so our next section deals with absolute max, absolute min. So let's take a look.
2.4.
This is 2.4. Absolute max and min. We're going to look at first possibility is on a closed interval. Here in this section, we're not going to graph those functions. We're just going to, we can, but we've done enough of graphing. So all I care about now is find the absolute min and absolute max of a function. On page 241, if you'd like to choose the first set, 9 through 38. 241, and the second set, and then I like to choose a word problem. Second set, 49 through 86 on page 242. The first set is on a closed interval, the first set of problems, and the other one is on an open interval. Or slightly more sophisticated problems as well. No one wants to choose? Thank you for the vote of confidence. I will choose if you don't. Okay, let's say 28. And then you can choose the other one. On 28, again, 28 on 241, we have f of x equals x to the fourth minus 2x cubed. The given interval is a closed interval, negative 2, 2. And the question, let's read the question. Find the absolute max min values of each function over the indicated interval and indicate the x values at which they occur. So find the maximum and also where. Of course, I have to find where the maximum is before I find the maximum. So in this case, all I care about is the first derivative and the function f of x between exactly what I am given, between negative 2 and 2. Yes, I have to find the critical numbers, but before I find the critical numbers, I have to find the derivative. In this case, you're right. We always start with the domain if we're asked to graph, but we are specified the domain here. Okay. So f prime is 4x to the third minus 6x squared. Since this is never undefined, I will set it equal to 0. I will factor out 2x squared and get x minus 3. And I should have asked you from the very beginning, what is the degree of this polynomial or this equation? 3. So I have to obtain 3 solutions. So what will you say those 3 solutions are? Of course, I will divide both sides by 2. That has no effect.
0, 3.
Twice 0, right? Because I have x and x equals 3. So is 0 in the table? In the domain? Yes, it is. Is 3 in the domain?
No.
No, so we don't care about it. I'm going to write 0. I'm going to plug in the function 0 because I need to find the point, right? We're asked for the point. We will always be asked for the point. When I plug in 0, I also obtain 0 for the function as well. And now I have to study the sign. So this is the first derivative. Let me write it one more time for it to be clear. So this is 2x squared x minus 3. I don't want to plug in numbers in something that is always positive. And since this is always positive, I don't want to care about it or worry about it. Why plug in the numbers, any number in 2x squared? So I will plug a number to the left, like let's say negative 2. Just give me the sign.
Negative.
Plug in a number to the right, and just tell me the sign.
Negative.
Aha. So it appears that this function does not have a local or relative min or max. And furthermore, it's always what? It's always decreasing. Very good, awesome. However, on a closed interval, I have to determine the endpoints, right? And now this was April's question last time. What about the square root of x? But it doesn't have a local or a relative, right?
Right.
It would have an absolute. So I have to plug in negative 2 in the function and positive 2. I go to my calculator. I punch in the function. I don't need these anymore. They can go. So we had x to the fourth. And then minus 2x cubed. Oh, of course. Okay, so now with second and table, all I need is negative 2 and 2. So 32 and 0. So I go back to my chart, 32 and 0. How is that possible? 4x cubed minus 6x squared. We had 0, 0. So did I put in the correct function?
No, you did.
I did not,
Wait, you did the f of x, didn't you?
but I have to.
Oh,
Okay, maybe I made some. Did you get the same answer?
Yeah.
Minus 2x cubed with 2 and negative 2. Okay,
And at 32 and 0.
okay. But let's think for a moment. So when we plugged in 0, I don't see any error. We can also look and see what's happened. Oh, I'm sorry. So negative 2 is 32. So the function has to be constantly decreasing. Well, how can I say that from 0 to 0 the function is decreasing? See my dilemma?
Mm-hmm.
And you did get the same numbers, right?
Mm-hmm.
So with negative 2, yes. With positive 2, yes, we do get 0. And when we plug in 0, we do get 0. So when we look at this, you don't have to do this. I just want to check something. So 12x squared minus 6x. So it does have an inflection point. That's what it is. It will have an inflection point. So 6x, and this is 2x minus 1. It will have 2 inflection points. That's what. Okay. It will have an inflection point at 0 and an inflection point at 1/2. Okay. Very interesting. I have not gotten this situation before. We're not asked to check. We're not asked to check inflection points here. We're only asked to find an absolute min and absolute max. So here's what I'm going to write. Absolute max at x equals negative 2 is 32. So negative 2 comma 32 gives us an absolute maximum. It happens that there are 2 absolute min. Say it again.
0 and 2.
Yes. So x at x equals 0 and x equals 2, and that absolute min is 0. So 0 comma 0 and 2 comma 0. And don't mind me for a second. I just want to look at this graph. I see it here. I just wanted to see it between negative 2 and 2. And I can go a little bit so I can see those points. So I can go to negative 4 and 4. Okay, so yes, it has an inflection point. But something bothers me because the function has, I know that it has an inflection point at this, and also has an inflection point at 1/2, obviously, as you see. The function is coming, opening upward, then it turns at 1/2, starts opening upward. But see, this function between negative 2 and 2 is not always decreasing. So I do have an error somewhere, right? So it's decreasing
Then
and then increasing. And this is negative 2 and this is positive 2. So we have to go back to the drawing board. Something is wrong. So let's go back. So what did I do? Very clear. Here's what I did. Okay, so I realized that something is wrong. So this is 3/2. Okay, makes no sense. I can't have 0, 0 and showing it increasing. My apologies.
What happened? What did we do?
Okay, so I factor out 2x squared, but in parentheses I wrote x minus 3 instead of 2x minus 3. And that makes a big difference. Huge difference.
Okay.
It makes no sense, right? The two rows have to work well together. I said, what is going on here? Because at the very beginning, I mean, in the second or two, I said something is wrong, but I didn't see the mistake, right? 2x squared times 2x is 4x cubed. 2x squared times negative 3 is negative 6x squared. It made no sense. How can it be constant? Right? Good. So then it's 0 here, not at 3. It's 0 here. So now when we plug in negative 2, yes, we got positive. Yes, when we plugged in 2, yes, we got. But I also have to plug in 3/2 in the original function. My apologies.
Oh, so from 3/2 to 2 is going to be increasing.
Exactly. It has to be. Can be 0. If the first derivative says it's negative, it has to be decreasing. But it's not decreasing. So this was our function, right? Correct. So now second and 1.5. So negative 1.7. Negative 1.7 approximately. Good. So going back to the drawing board, this is okay. This portion is okay. But now I have to plug in, let's say, 1.9 in the derivative to study the sign. Of course, it's going to be positive. We know that, right? So when I plug in here 1.9 in the derivative, I would get a positive number. We know that because it's increasing. We already looked at it. So let's see. Let's do that. So in y equals, we have, what was it, 4x cubed minus 6x squared. Okay. And when I plug in, we said 1.9. We know we have to get a positive number. There's no question. Because otherwise it would have made no sense. So this is positive. And that means indeed, and now it makes sense.
So then that's the minimum.
Exactly, and that's the absolute minimum, and it happens to be a relative minimum also because it's in the middle of the interval somewhere.
Now the minimum is it 3/2, 0?
3/2, negative 1.7.
Okay.
So this is not the point. This is where the critical number is. So now we have to make the correction. The absolute maximum is still okay. The absolute maximum is at negative 2. No question there. The absolute minimum is not at 0 and not at 2, but wrong, but at 3/2. And how much is the absolute min? How much is the absolute min? So absolute min at x equals 3/2, which is, value is negative 1.7 approximately. So 3/2, negative 1.7. That's the absolute min. What about 2, 0 and 0, 0? Nothing. So this one is also a relative min. This one, however, negative 2, 32, is not a relative min because it's at the end point of the interval.